Hi everyone, we're going to start talking a little bit more about simplifying radicals. And again, sticking with the square roots. We're going to go into dealing with variables today, and we're also going to go into dealing with operations with square roots. Alright, so first let's look at the expanded form. So if I have a to the first power, what would that look like expanded form? Well, this really just means I have an a. So with that a, how many pairs do I have? Well, a pair means two. So since there's only one a, I don't have any pairs. All right. How many would then be left over? Well, just one. So I have one left over. All right, let's see what happens if I expand out a squared. That's a times a. All right, so how many pairs do I have? Well, I can make a pair just like that, and I have a pair. All right, so we can say that we have one pair, right, and there's none left over. Right, what about a to the third power? Well, I can say that I have a pair of a's right there. Right, so I can make a pair like that, so I got one pair, and I have one left over. What if I have a to the fourth? How many pairs can I make out of that? Well, I've got a pair of a's there, and I have another pair of a's there. So in this case, I was able to make two pairs with none left over. All right, how about a to the fifth? How many pairs can I make here? Well, I can make a pair of a's there, and I can make a pair of a's there. So again, I was able to make two pairs. This time, though, I had one left over. And what about a to the sixth? How many pairs can we make there? Well, oops. I can make a pair here. I can make a pair here. And I can make a pair here. So I was able to make three pairs. And again, none were left over. All right, did you notice a pattern at all? So think about what kind of pattern you may have seen. And how could you describe that pattern? So the pattern that I notice is that if my exponent is even, I have none left over. If my exponent is odd, I always have one left over. Another pattern I notice is that I can divide that number by 2. So 2 divided by 2 is 1. It told me how many pairs I had. 2 can go into 3 only one time. 2 can go into 4 2 times. 2 can go into 5 2 times, and then one left over. 2 can go into 6 3 times. Right? So my number of pairs can be determined by how many times 2 can go into the exponent. So that's one way to look at it. The number of pairs can be determined by how many times 2 can go into the exponent. So that's one thing I noticed. And then another piece to the pattern, which we already said, was that if the exponent was even, there were no leftovers. If the exponent was odd, there was always one left over. All right, so two different little patterns that we could see. You could utilize this to help you when we go into simplifying square roots that involve variables. All right, so let's simplify some of these here. All right, so a to the 7th. So I'm going to show you the long way, and then I'm going to show you the short way. And you can use whichever one you prefer. Some people like using the expansion way, the expansion method, and some people get the shortcut, right? The patterns that we can see. So when I am using the expansion, so a to the 7 is the same as saying 1, 2, 3, 4, 5, 6, 7. It's a lot of a's, but we can do it. So when we're doing square roots, remember, just like when we were dealing with numbers, we're looking for pairs. And we are always looking for pairs in square roots. Remember Jailbird Johnny from class? Right, so we're looking for pairs. So how many pairs can I find? I was able to find 3 pairs. Right, so I can pull out every single one of those. So I can pull out one A for each pair. So I have an A to represent the first pair, I have an A to represent the second pair, and an A to represent the third pair. And then I have one A left over. Now remember that pattern, if it's odd, we'll always end up with 1 left over. So now, A times A times A, well, I can simplify that, and I can just say A to the third. And there we go. And that's the long way. Or I could say, since I'm looking for pairs, how many times can 2 go into 7? Well, 2 can go into 7 3 times. And since it's odd, there's 1 left over. That's the quick way to do it. So you don't have to go through all of this work here if you get the quick way. All right, let's try this one here. All right, if we were to do the long way, that's 15 x's. All right, sometimes I like to break it down like this and just make my pairs. X, X, so there's 2, 4, 6, 8, 10, 12, 14, and then 15. All right, and then I've got 4 y's. So there's 2, 4. So I can go ahead and I can look for my pairs. So how many pairs do I have? 1, 2, 3, 4, 5, 6, 7. So I have 7 pairs of x's, and I have 2 pairs of y's. So 7 pairs of x's. So I can just jump right to x to the 7th power. And that 7 represents how many pairs we have, and then y to the 2nd power. Again, I jump to how many pairs do I have. So the exponents will tell me how many pairs we have. And then we had 1x left over. So that's the long way. And again, the short way, following that pattern, is how many times can 2 go into 15? Well, 2 can go into 15 7 times. And since it's odd, there's 1 left over. 2 can go into 4 2 times. And then it's even, so there's none left over. Right, let's try this one here. So n to the 8th. So I can make 8 n's. So there's 2, 4, 6, 8, and then I need 5 n's. So 2, 4, 5. Alright, so now I'm going to find out how many pairs I have. So I have 4 pairs of n's, none left over. And I have 2 pairs of n's with 1 left over. So remember that pattern, 8 is even, so there won't be any left over. 5 is odd, so there'll always be 1 left over. Alright, so the answer would be n to the 4th, n squared, and then that 1 n left over. So I have 4 pairs of n's, so that's why we wrote 4 here. I have 2 pairs of n's, so that's why I wrote 2 here. The shortcut would have been, what's 8 divided by 2? 4. Right? 2 can go into 8 4 times. 2 can go into 5 2 times with 1 left over. And let's try one more. Alright, here I have just an x, and then I have 3 y's. So there's 2, 3. And switch my things around. Alright, so I don't have any pairs with the x, but I have one pair of y's. So I can pull out one y, and then left inside is the one x that was left over and the one y that was left over. And now I'm done with that one. So again, you can see how many times can 2 go into x, or into 1. So remember there is actually a 1 here. You just don't see it. Right? So 2 can go into 1 0 times, so until we don't have any on the outside. 2 can go into 3 1 time, right? And then there's 1 left over. Alright, so now let's go ahead and apply it along with what we did last time. So now we're going to go ahead and we're going to add back in some numbers. So I'm going to first simplify the 8. I'm going to use my birthday cake. So remember our birthday cake from last time? So I'm going to give myself some space. So I'm going to take my 8 and I have to divide by prime numbers. What were those prime numbers again? Oh, that's right. We had 2, 3, 5, 7, 11, 13, 17, 19, and so on. Alright, so we'll just put those there. Usually 13 is probably like the biggest one we usually use. Alright, so we start with our smallest. So 2 is the smallest one that can go into 8. It can go into 4 times. 2 can go into 4 2 times. And 2 can go into 2 1 time. And then once I hit the 1, that's my birthday cake. Alright, so again, I'm looking for pairs. So I've got a pair of 2s. I got one pair of 2s, and I got 1 2 left over. Right, and now, let's take care of those W's. So I've got 3 W's. 1, 2, 3. And then I have 2 X's. Alright, so let's find out how many pairs we have here. So I have a pair of W's and a pair of X's. So I'm going to put all of that together. So all my pairs come out. So a pair of 2's, a pair of W's, and a pair of X's. All my singles stay inside. I have a single 2, and I have a single W. Done. Not too bad. Alright, I got this negative sitting on the outside, so remember there's actually a negative 1 sitting there. So now I'm going to deal with that 32, but we don't want to forget about that negative 1. We're going to use him later. Okay? So first though, let's birthday cake that 32. So the smallest prime number that can go into that is 2. And that can go in 16 times. 2 can go into that. 2 can go into that. And 2 can go into 4. And 2 can go into 2. One time. Alright, now I'm going to take a look at my variables. So I have 5 W's. There's 2, 4, 5. And then 3 X's. 2, 3. Alright, I'm going to look for all my pairs. So I have a pair of 2's and another pair of 2's. I have a pair of W's and another pair of W's and a pair of X's. Remember with the variables, if you get the shortcut, you get the pattern. You don't have to show this part of the worksheet. Right? I'm just going to keep showing that for people who may not quite get that pattern. Alright, so now what do we do? Alright, well, let's not forget about this negative 1. So this negative 1, I'm going to bring them down. So negative 1 times. Alright, what else are we pulling out? Well, we're pulling out 2 2's. So I've got 2 times 2. And one pair, 1 2 to represent each pair. Okay, so 2 to represent that pair, and then another 2 to represent that one. I've got 2 pairs of W's, so we can easily write that. I can write 2 separate W's, or I can just quickly go W squared. And then I've got 1 pair of X's. Left over inside is a 2, a W, and an X. Alright, now let's just kind of take all this, put this all together. And so all of that together. So negative 1 times 2 times 2 is going to give me negative 4, W squared X, 2WX. Done. Let's try another one. And this time we've got a negative 6 sitting on the outside. All right, you may recognize 81 as a perfect square. If you do, great. Just jump right to it. The square root of 81 is 9. If you don't recognize that, then go to your birthday cake. So 81. So the smallest prime number that can go into it is 3. 3 can go into that 27 times. 3 can go into 27 9 times. 3 can go into 9 3 times. And 3 can go into 3 1. And then I can break down my variables. So W, so 2 and 3, and then I have 2 x's. So now we can find all of our pairs. So I have a pair of 3's and another pair of 3's. And you're going to notice I have no numbers on the side left over. That's because 81 is a perfect square. And then I have one pair of W's and one pair of x's. Alright, so we have that negative 6, and it's just going to come down, times, I have two pairs of 3's, so 3 times 3. And then I have one pair of W's and one pair of x's. The only thing that was left over was this W. I have no numbers left over on the side, and I have no x's left over, so one W is left over on the side. Now I can multiply all of this back together, and we end up with negative 54 WX times the square root of W. And let's give this one a try. Be careful, because this one has not only a number, but also a variable sitting on the outside. Alright, but let's start with that 10, and let's birthday cake the 10. I'm going to do it over here, just where I got one more. So I can divide 10 by 2, 5 times. Divide 5 by 5, 1 time. So we're going to notice there's no pairs in my numbers here. So no pairs, only singles here of my numbers. That means I'm not going to be pulling numbers out. But let's break down our variables. So I've got 6 W's. So there's 2, 4, 6. I've got 4 X's, so 2, 4. And then I've got 1. Alright, so now inside that radical I have a 2, a 5, my W's, my X's, and my Y's. I just kind of broke everything down. And just throw it all back together. And then all that 2x. Alright, so now look for those pairs. No pairs here. But I do have a pair of W's. I have 3 pairs of W's. I have 2 pairs of X's. And then a single 1. So all my pairs are going to come in. Alright, so I've got 1, 2, 3 pairs of W's. So I've got 2 times X times 3 pairs of W's times 2 pairs of X's. And then left over inside, since the 2 and 5 aren't coming out, I can put them back together. And this is 10. 1. Alright, and be careful here, because when I go to smush all this together, I've got this x and this x squared. I can actually put them together. And that's an x to the first. And if we remember our exponents, we can add them together. So 1 plus 2 is 3. So we get 2w cubed x cubed 10y. You're not going to get ones like that very often. That's a pretty challenging one. Alright, let's go to the next page. Now let's look at operations with radicals. Now that we've got simplifying down, we're going to look at how we add, subtract, and multiply radicals. Alright, so when we're doing operations, we don't have to worry about variables. Phew, thank goodness. Alright, so when we're doing operations with radicals, think of adding and subtracting radicals as combining like terms. in order to add or subtract radicals, the radicands, that's the numbers under the radical sign, must be the same. We only add or subtract the number of the coefficients of the radicals. So in order to add and subtract them, okay, these numbers here that are underneath the radical have to be the same. It's the only way. So in this case, they are. So in this case, I've got radical 7 and radical 7. That's great. So what that means is I'm going to add together the coefficients. So 2 plus 4 gives me 6. And then just like like terms, I then just carry down that same square root. Right? The radical 7 just comes down. We're done. Same with subtraction. So they have the same radical. So now I can, in this case, subtract the coefficients. 5 minus 6 gives me a negative 1. The radical stays the same. And we want to write everything in the most simplest form. 1 usually doesn't show up, so we just say negative radical 6. Done. Now, what happens if we have 3 numbers? Or 3 terms. They're all terms. We're just using radicals instead of variables. So we can do the same thing here. I have a negative 1. So they all have the same radical. So now I'm just going to combine the 3 coefficients. So I end up with 2 minus 8, which gives me negative 6. And then that radical 5 just comes down. Done. Alright, now be careful here, because not all of the radicands are the same. So look, I've got a 2, a 10, and then a 2. So the only ones that are actually like terms are this one and this one. So I can combine my coefficients of those two. So 9 plus 6 is going to give me 15 radical 2. But what about that minus 10? I'm just going to carry it down. Minus radical 10. And then I'm done. Well, that wasn't so bad. Alright, let's take it up a notch. Sometimes we have to simplify our radicals first. And so sometimes we have to simplify our radicals first. We can see here that they're not the same. Right, so let's work on simplifying them first. So I'm going to simplify the 18. I'm going to birthday cake it. So I can divide 18 by 2 9 times. Divide that by 3. Goes in 3 times. Divide that by 3 1 time. And then I can birthday cake my 8. So 2 can go into 8 4 times. 2 can go into 2 2 times. And then 2 can go into 2 1 time. So here's what we have. I got a pair of 3s and I have a pair of 2s. So right now this is what we're looking at. So this one here looks like this. I got 5 times, I have a pair of 3s and a 2 left over. This one here, I'm going to get that negative sign, looks like this. Negative 3 times, I have a pair of 2s and then a 2 left over. Alright, so let's kind of put all this together. So 5 times 3 gives me 15. Negative 3 times 2 gives me negative 6. Square root 2. Now I have like terms. So they both have the square root of 2. So now I can subtract 15 minus 6. Gives me 1. Oops, not a 5. Sorry about that. So give me 2. Right. Okay. Let's take a look at another one like that. Alright, so in this case, we've got just that squirrely negative sitting out all by itself, so it's really a negative 1. 3. 3 is one of our prime numbers that can't be broken down anymore. So I know I don't need to simplify that one. But 27, let's see if we can simplify it so that we can try and combine those together. So I'm going to birthday cake my 27. I'm going to do it over here. And divide that by 3. And that goes in 9 times. Divide that by 3. 3 times. Divide that by 3. And that goes in 1 time. Alright, so here's what we have. I have a pair of 3s. So, this guy here, I'm not really making any changes to. This one, I've got that plus 2. So I've got the 2 times, I've got a pair of 3s. And then I have the 3 left over. So now I've got negative 1 radical 3. That's a positive 2. So plus 6 radical 3. Combine those together, and we end up with 5 radical 3. And that's not so bad. Not so bad. Alright, now let's see what happens when we want to multiply radicals. I actually like this one a little bit better. So in this case, we will multiply our coefficients together. We're going to multiply the radicands together, and then we're going to simplify. So it's going to kind of look like this. I'm going to take this problem here, and I'm really going to do negative 4 times 3. Okay, so multiply the 2 coefficients together. And then I'm going to do 18 times 6. Alright, so I get negative 12. And then I'm going to go to my calculator, and 18 times 6 gives me 108. Right, multiplying 7. Now I need to simplify. So let's see how far we can simplify that 108. So I'm going to birthday cake the 108. Give myself some room. And that's even, so I can divide it by 2. And when I do that, I get 54. 54 is even, so I can divide that by 2. And when I divide that by 2, I get 27. 27 can be divided by 3, I get 9. 9 can be divided by 3 times. And 3 can be divided by 3 times. Alright, so now look for our pairs, because we're doing square roots. So I've got a pair of 2's, and I have a pair of 3's. Alright, so we got that. Negative 12 has got to come down. Times, I had a pair of 2's, and I had a pair of 3's. And then I had a 3 left over. Like that, like that. Now I can multiply all that back together, and we end up with negative 72 on the outside. Radical 3. I think I kind of like multiplying a little bit. Alright, let's come over to this one. So on this one, I actually don't have a coefficient here. So remember that missing coefficient's just a 1. So what I'm really looking at is I've got my 3 times 1. And then underneath, I've got 2 times 26. So I get 3. And then I can go to my calculator, and 2 times 26 is 52. So now I need to check to see if I can simplify that. So I'm going to birthday cake 52. So 2 can go into 52 26 times. 2 can go into 26 13 times. 13 is one of our prime numbers, so the only number that can go into that is 13. Alright, so now I've got a pair of 2's. So I can bring down my 3 times, I need 1 pair of 2's, and then I have 13 left over. So 3 times 2 is 6, radical 13. Let's do a couple more together, make sure we got it. So here, again, I'm going to do my 2 coefficients, so 3 times 5. I'm just going to jump right to what that equals this time, so 15. and then 2 times 10 is 20. Once you get the hang of it, you can kind of skip writing out the whole multiplication step. And you just jump to what that equals. So now I can multiplicate my 20. 2 can go in 10 times. 2 can go in 10 5 times. 5 is one of our prime numbers, so it can be divided by 5 one time. And then I've got a pair of 2's. So I'm going to bring my 15 down times one pair of 2's. And then I have a 5 left over. 15 times 2 is 30. And then equal 5. Done. Alright, last one. Alright, so again, we just have that negative floating there, so that just really means it's a negative 1. So when I go to multiply, I've got negative 1 times 7, which is just negative 7. 3 times 6 gives me 18. And I'm going to birthday cake the 18. Look for my pairs. And 3's. So I'm going to bring down that negative 7 times the 3 to represent my pair of 3's, and then I just have the 2 left over. So I get negative 21 radical 2. Done. Alright, so I know this is kind of long, but that takes us through pretty much everything square roots. So please make sure you watch this video, come to class next time, we'll kind of go over this a little bit more in class, ask questions, come see me during office hours, take your time with this stuff, and I am here to support you with whatever you guys need. I will see you in class next week.